Manufacturing is eating the world. AI transformation, or AX, is no longer optional. It's becoming a necessity for survival in the manufacturing industry. It's more effective to teach AI to domain experts than to teach domain expertise to AI engineers. We have helped reduce the design time for a car brake system from 1 month to just 1 minute. The biggest challenge in engineering is the time and cost of the iterative product development process. Hello everyone, I'm Namwoo Kang, CEO of Narnia Labs. While AI has been driving rapid innovation across many industries, the pace of transformation in manufacturing remains relatively slow. Today, I'd like to share some key challenges I've observed while applying AI to real-world product development and discuss what we should consider before adopting AI in this field. Let me begin with a brief introduction about myself. I come from a multidisciplinary background. My undergraduate major was mechanical engineering. I earned a master's degree in technology management and a PhD in design science from the University of Michigan. I also worked at Hyundai Motor Company, which gave me valuable hands-on experience in manufacturing. Currently, I lead the Smart Design Lab at KAIST, and I also serve as CEO of Narnia Labs, a spin-off company from our lab. Now let's move on to the main topics of today's talk. We'll begin by asking why AI is important for product development. Then I will share some strategies for effectively applying AI in this domain. And finally, I will introduce Narnia Labs. About a decade ago, we often said software is eating the world. At that time, software platforms, especially those from Silicon Valley, were disrupting nearly every industry. But now we're entered a new phase. Manufacturing is eating the world. China, with its abundance of AI talent and infrastructure, is rapidly implementing AI-powered physical systems, driving a new manufacturing revolution. As shown here, manufacturing still represents a larger share of Korea's GDP, about 24%, ranking 10th globally. However, Korea faces a crisis: an aging population, a shrinking workforce, and weakening competitiveness against China. This is not an issue that only Korea faces. That's why AI transformation, or AX, is no longer optional. It's becoming a necessity for survival in the manufacturing industry. So why is AI transformation especially critical in product development? If we plot the value added along the product life cycle, we see what's called smile curve. The production phase lies in the middle, but the greatest value creation happens at both ends, particularly during pre-production, where product development takes place. This means that applying AI to product development can create the largest impact within manufacturing. Now, let me share some strategies for effectively applying AI in product development. We can think about this from 5 perspectives: problem definition, data, model, execution, and skill. Let's take a closer look at each of these. The first perspective is problem definition. We all know that in manufacturing, domain knowledge is critical. As the saying goes, don't just solve the problem right, solve the right problem. Without deep understanding of the domain, even the best AI model can end up solving the wrong problem. In manufacturing, AI should be treated as a tool, not the ultimate goal. While AI itself is becoming easier to learn, manufacturing requires deep expertise: physics, materials, design, and hands-on experience. That's why many companies are realizing it's more effective to teach AI to domain experts than to teach domain expertise to AI engineers. The issue is that a lot of students in universities are only studying computer science, so we're ending up with AI experts who don't have any domain knowledge. The second perspective is data. Many manufacturing companies say they have a lot of data, but in reality, the data is often inconsistent, incomplete, or unusable for AI training. Data quality influences outcomes even more than the model itself. If good data doesn't exist, we must create it. And that means building system of automatic data collection and pre-processing is important. Since manufacturing data is sensitive, companies don't like to share it or put it in the cloud. That's why automating data preparation often requires far more time and resources than developing the model itself. In fact, in manufacturing, AI is often manual labor disguised as intelligence. AI just eats data. Engineers are the one who set the table and feed it. Next is the model perspective. If we compare two types of AI models, one that performs reasonably well across many tasks, and another that excels in one specific area, which one do you think is better suited for manufacturing? The answer is the specialized one. Manufacturing problems are diverse, complex, and difficult to generalize. And there are few public data sets. That's why manufacturing AI is harder to get into. It needs experts who really understand the field. Even when using agentic AI systems, domain-specific agents are essential to achieve meaningful results. The first perspective is execution. Many companies make the mistake of trying to build a big AI house all at once. Instead, we should start with one brick at a time. Also, there are a few more things to keep in mind. Focus on the long-term vision, not short-term wins. And start small with a proof of concept. Identify gaps quickly and improve continuously. Recognize both the limits and potential of AI. Avoid both blind optimism and excessive skepticism. Tackle high ROI problems first. And don't try to do everything alone. Collaborate with capable startups and partners to accelerate progress. Finally, let's look at the skill perspective. How to maximize efficiency when using AI. First, let AI do what it does best. AI is fast but clumsy. Humans are careful but slow. So let AI handle high volume tasks where speed matters more than perfection. Second, stop chasing perfect accuracy. There is no such thing as a magic wand that is both fast and perfectly precise. AI's value often comes from being fast enough, not flawless. Third, use AI only where AI is truly needed. Many tasks can be automated without AI. Don't use a sledgehammer to crank a nut. And finally, develop AI from the user's perspective. Avoid flashy but impractical systems. Focus on creating simple, intuitive tools that users can easily adopt and benefit from in their work. Finally, let me introduce Narnia Labs. Here is our vision. To become the world's leading generative AI company, revolutionizing the product development process in manufacturing. We provide AI solutions that significantly reduce development time and cost through generative, predictive, and optimization technologies. For example, we have helped reduce the design time for a car brake system from 1 month to just 1 minute and generated over 30,000 wheel design candidates automatically. We are already working with leading manufacturers in Korea and also with several global OEMs in Europe and the US. The biggest challenge in engineering is the time and cost of the iterative product development process, the long cycle of design, simulation, test. Our goal is to shorten this process using AI. We offer two key approaches, predictive AI and generative AI. Predictive AI learns from historical simulation or test data to instantly predict the performance from new designs. This allows designers to iterate much faster without waiting for simulation or physical testing. Generative AI takes it one step further. It creates new design candidates, predicts their performance, and recommends optimized solutions. By combining these approaches, we can dramatically accelerate development while reducing cost. Narnia Labs has already accumulated extensive real-world experience across the entire manufacturing industry. In the mobility sector, we have used AI to design most of the major systems and components that go into automobiles. Our AI technologies have also been validated in real industrial setting, not only in consumer electronics and power electronics, but also in heavy industries, energy, robotics, factories, and even nuclear reactor design. Through these projects, we have gained tremendous domain knowledge and hands-on experience in manufacturing. This means we now possess the ability to define problem effectively and to generate high-quality engineering data. The two key capabilities I emphasized earlier for manufacturing AI. To make AI accessible to domain experts, we developed AselanX, a no-code AI platform that enables domain experts to implement SOTA AI models for solving their own design problems, along with an inference application for deploying the trained models. Building an AI model in AselanX involves 6 simple steps: import, process, build, train, test, and deploy. Users can upload engineering data, whether 1D, 2D, or 3D, and the platform automatically pre-processes it for AI use. They can then define input and output variables, select models, train them, test performance, and finally deploy the model as an API or GUI apps for others to use. All of these steps can be performed without coding, through a simple visual workflow interface. Users can also customize workflows using low-code options to suit their specific goals and design processes. These workflows are fully extensible. Users can combine multiple AI modules such as generative AI, predictive AI, and optimization AI to tackle complex engineering problems end to end. Finally, here's a glimpse of our product interface. Thank you very much for listening. If you want to learn more about our solution AselanX, feel free to contact us by email.